Hey everybody, this is Larry. This is day 14 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, drop me on Discord. Let me know what you think about this one while the problem is loading. Before I start, want to, you should skip forward if you like, but I just want to show you this clip of me doing the ultra. It's just me saying, this is mile one, and that you'll see it. Yeah. Let's go. Let's do it. Oh, 1 mile, baby. Yeah. Got nothing. Bridge. Brooklyn and Manhattan. Yay. Yay, 2 miles. 3 miles, yay. 4 miles, baby, yeah. Yay, 5 miles. 6 miles, baby, yay. Look at this, look at that face slow down. Oh wait, 7 miles, yay! 8 miles, baby, yay! 9 miles, yay! Yay, 10 miles, 10 miles, baby, almost halfway. 11 miles, yay! Video, yay, 12 miles. Don't get my video, 12 miles. Yay, 13 miles. Almost there. 14 miles, baby. Yeah, almost there. 15 miles, baby. 5, and then another 10. 16 miles, baby. Yay, 204th Street. Yay, the tip, just the tip. Yeah. Yay, 17 miles. Yay. 18 miles. I don't have enough fingers. 18 miles. Yeah. Yay, 19 miles. Yay. Yay, 20 miles. Yay. Yay, 21 miles. Yay. Yay, 22. Yay, 23 miles. Yay. Yay, 24 miles. Yay, almost there. Yay, 25 miles. Yay. Yay, 26 miles. Yay. $7 Coke. Yay, 27 miles. Yay, 28 miles. Yay, almost there. Yay, 29 miles. Yay, 30 miles. I want to thank you. Yay, 31 miles. Almost there. Still. A lot of people. 32 miles, yay! Almost there. Yay, we made it. Standing Island Ferry. Yeah, hope that was okay. I don't know. I didn't really put that much effort into it, only because, because I was just so tired for most of it. But yeah. Also shows, I just want to show it because well, one is because of humble bragging, but also, these things are not impossible. It's just, you just have to put time into it and effort into it. And in fact, that was on Saturday, so like 3 days ago, 2 days ago. Yeah, 3 days ago. And today I did a speed trial on 5K or 3 miles, a little bit more than 3 miles, just to kind of get my legs like shaken out a little bit. So yeah, so I'm really tired, but I did take a nap, so it should be good. All right. Without further ado, let's take a look at today's problem. 719, find the cave's smallest pair distance. Okay, so the distance of a pair of an integer a and b is defined as the absolute difference between them. Okay, given an integer array nums and integer k, return the kth smallest distance amount or pairs nums of I and nums of j, whereas I is less than j. Okay. And yeah, and okay, and this is one indexed. Not a big deal either way. What is n? N is 10 to the 4th, so and k could be really big. Though the answers are only up to 10 to the 6th. Don't know. So maybe we can do binary search as one of my thing, but before we even get there, I want to say that obviously you cannot just create all of them, because n choose 2 is going to be 10 to the 8 over 2, which is just way too big, right, to consider. And yeah, and it's just too slow. But the first thing I noticed is that it's 10 to the 6, so maybe we could do a binary search if we have a way to do a binary search, right? How would we do a binary search for each number, right? So then binary search on each number could work, right? Then it's just n log this thing. Because the idea for binary search would be that for each number, you're trying to find the number of pairs that are less than some other number, and for that you just binary search on the number, right? Because for example, if you have, I guess these are kind of poor examples that they give you, but if you have, and let's say we always sort them because we are going to sort them anyway, something like this, right? And you know, maybe we want to say we want to binary search on the answer, and we want to see, okay, what if the distance is 1 away? Well, for 1 away, then we count how many pairs are there. If we and we could do that by n log n, right? Because for each number 1, for 1 we have one number that is within 1. For 2, there's 2 numbers that are within 1. For 3, there's 1 number that are within 1, right? And maybe and that's fine. And maybe you can even, I say n log n because I was lazy, because I said that for 3 you can binary search for 2 and 4 and then see how many numbers are between 2 and 4, right? Something like that. But you probably can actually use a 2 pointers algorithm, right? And we use a 2 pointers algorithm, then this is just n log n. So that should be pretty okay. I think that's what I'm going to do. I'm just kind of, yeah, I think that's what I'm going to do then, right? So yeah, so this is binary search on the answer. So this lower bound is going to be 0. Upper bound is going to be, say, I could say this, but we should also just sort anyway. So then now this is just the last number, right? Oops. And of course, the way that I write binary search, I always do an inclusive bound, meaning that so that when this range is exactly one number, that's your answer, right? And then now if good of mid, if good, what does good mean, right? So we have to define that so that it's more precise. So good is so what are we saying with k? With what are we trying to do with k? So we're trying to find the kth smallest pair. That means that, and for me, I always get this wrong, so I'm trying to be a little bit slower and deliberate and precise. Or not wrong, but just like off by ones and not careful, right? So the kth smallest means that there are the smallest number such that there are k minus 1th smaller I think that the thing is that you have to want to be precise because of the case where numbers are the same, right? If they're distinct, it actually is very easy and it doesn't matter. But because of the duplicates, you have to be really precise here, and I don't think this is quite right. I mean, you can do it that way, but there are at least k smaller or equal numbers, right? Okay, I think that's how I want to do it. So then now the good function would be just or smaller pairs rather. K smaller or equal pairs, right? Yeah, this is return true. Thing. Yeah, the off by one that I'm thinking about is the or equal part, right? So I just want to be precise. So let's say they're all right. That means that this number is good. So that means that this is a possible answer, and we want to try a smaller number. Yeah, we want to try a smaller number. So right is equal to mid, else left is equal to mid plus 1. Is that right? Because yeah, okay. And then we just return left, and that's basically the structure for binary search. Really bad at these things actually. Okay, and then now we just have to find the k smallest or equal part. So then maybe we have a count is equal to 0. Return count is greater than equal to no of k. Whoops. And then here we can do binary search, but I think we'll just we'll try the 2 pointers first, and then yeah. Yeah, right. So I think binary search is also fine, to be honest. But yeah, so then now we have for left in range of n, so right is equal to 0, say, and then now we have a while right is while nums while right is less than n, and num sub right is well, this is true, or if it's equal to, then we want to keep going, because then now will be, yeah, okay, fine. And then now the count is just equal to something like right minus left. We don't have to do the plus 1 because we don't count itself. And this is, of course, this is 2 pointers. For example, we have something like this, then we just only look at one side. We go, okay, we have 2. Let's say 1 is a stupid number actually to find. Let's say we want the target is 5, right? Then now we have our left pointer at 2. The right pointer would be at 8, because then now you have 2 numbers in between, right? So this may still be a little off by 1 actually, because right is the number that does not contain this number. So this should be this. And this is wrong. No, this is wrong. If this is greater than it, then you keep going. Doesn't make sense. Yeah, I messed this up. Okay, there you go. And this has the benefit of also, if it's negative, then you're on the left side of left, and then you just keep going. But yeah, but the first thing we're doing is that we're also just looking at bigger numbers, right? Oh, this is not k. I keep on writing k in random places. This should be target. Yeah, so if this is 0, then it just also keep going until right is equal to n, and then n, yeah. Keeping in mind that here we only look at one direction, right, because of all the numbers that are bigger than it. We don't have to look to the left because of symmetry, right? yeah, symmetry being that if, let's say we want to say, okay, 2, in this case, we also connected it with 1, but when 1 is the left pointer, it would have also considered 2. So that's basically the thing. Okay. Alright, I think this is good to at least give it a spin. Hopefully this is okay. I mean, these inputs are really crappy, 0, 0, and 5, come on. So I don't know, this gives me no confidence. But I am lazier than I am, constructing help case. I mean, obviously on an interview, definitely come up with some test cases. With nothing else, okay, fine. Let's just do a couple with like, I mean, we could write something here instead. For example, maybe nums is equal to, say, I don't know, x for x in range of 10,000, which is the max, and yeah, right, and then print nums. I'm a little bit lazy, so I'm just gonna write it like this, because then now you could copy this paste into the thing. Oh, well, I guess not, apparently, because it just dots it. Okay, fine. Right, we could try that out. I guess that's too big. Okay, well, that's still kind of is that too big? Okay, 2, 4, 5, 3, 1. Yeah, I mean, and the other thing that we're looking for is just running time. It seems okay, so I don't worry. All right, let's just give it YOLO submit. Oh, got it right on the first time. I mean, I don't remember this problem, but apparently the thing that I was just questioning is I got 2 wrong answers last time. So it's always nice to kind of get it right this time. But I also am curious why I submitted 3 times. So yeah, all right. But before, I mean, I'll go over this afterwards. But I want to go over this solution. So right is going to be the range of the numbers, which is 10 to the 6, right? So this is O of log R, where R is at most 10 to the 6. Oops. Right? Number of loops, right? Number of iterations. And this is just linear. As you can see, this is should be clear that this is linear, right? This is O of n, linear time. I would also say that I did do this one much slower than I normally would, so in a good way, like I was more deliberate. But yeah, linear time, right? So this basically means that this is going to be O of n log r, which is or in total this is O of n log r time, right? And plus n log n because of the sorting that I almost forgot, honestly. But yeah, and in terms of space, it's going to be O of n space just from the sorting. But yeah, and as I said, if you do a binary search here instead, that's probably close and okay. It just adds an extra factor of log n, which is like 10 times slower, but okay, well, you know, in the worst case only. But yeah, that's all I have for this one. This concept of binary searching for the answer comes up a lot, so you definitely should be familiar with it. This I think is coming upable, but yeah, and this was 2 years ago. That was a rough time for me actually, but I am curious what I did. No, I did the same thing, but oh, except I did the binary search. Oh, I double counted this. So yeah, this is the thing that I was saying about going left and right. Well, you don't need to do left and right because of symmetry reasons. And then did I fix it? I don't know if I fixed it, but I definitely did not fix it. And then eventually got it right. That is wild. How? Oh, because I divided by 2. That is a... Did the other one have that? No, I guess so. Huh. That's wild. I mean... And then I did it again. Yeah, this time I got rid of the count over 2. Looks okay. Oh, and this is the one that I was talking about. So past Larry kind of got there eventually. I even did this thing, but I defined this a little bit differently. That's why it's easy to make mistakes. And then I did one more optimization, but I just binary search in the beginning, and then I so I did eventually got to the linear good thing. I mean, I guess this is but no, this is just log n once though, so it's not n log n. So yeah, overall pretty. I mean, I guess the same thing. That's all I have for today. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.